This is a belt that gives you a sixth sense. And while it doesn't help you see dead people, thank goodness, the sixth sense it gives you kind of makes you superhuman. This is the Pigeon belt, and I made it so that whoever's wearing it can always have an intuitive sense of direction. Why is it called the Pigeon belt? Well, pigeons are the smartest animals in the world. That's a lie. But they are amazing, and they're very cute, and they have a strange little organ in their heads that's sensitive to the Earth's magnetic field, hence homing pigeons. They always know how to get home. And I thought, wouldn't it be cool if we could augment our bodies with this same sense of direction, the same sense of like being able to tap into the Earth's magnetic field and always know which way north is. In this video, I'm going to tell you how I made this dumb idea into an actual product that works, and you can decide if you think I should actually manufacture it and sell it on Amazon. But first, where did this idea come from? When I was 10, I read the Science article about a blind man who had rigged an electronic compass to a set of electrodes that he put on his tongue so that he could see what direction he was facing by feeling. And my mind was just blown. I thought, wait, it would be so cool if you didn't have to use your eyes to understand what direction you were facing, but if your body just through touch understood this. But I had no idea how to make it. Fast forward way too many decades, and I've learned some of the things. Now it actually turns out you can just make something as silly as this, a belt that knows which way north is and haptically vibrates just a little buzz whenever the wearer is facing north. That way you don't have to look at a screen, you don't have to look down, you don't have to take your phone out, you don't even have to have a phone. Pigeons don't have phones. And what if you didn't even have to think about it? Your body would just intuitively know what direction it was facing as you moved around the world, as you explored a new city, as you were lost in the jungle. So here's how I made this thing. First, I found a compass chip and I hooked it up to an ESP32 microcontroller. I used the Arduino IDE on my computer to read the compass headings, but the data was absolutely garbage. I mean, it was supposed to change at 360 degrees as you rotated it, but none of the readings made any sense, and they changed depending where in the room I was standing. They changed depending on what breadboard I'd plugged the chip into. It was a total nightmare. And after banging my head against a wall for a couple weeks, I thought, okay, you know what? I just need an easy win. So I put the compass problem aside, and I worked on a different part of the project, which was hooking up the buzzer. I rigged up an L9110 with a DC motor to the ESP32, and I laser cut a little wooden circle with the axis off-center. Because what happens when you put an off-center object on a motor is the whole thing kind of vibrates because of centripetal force. And this is called an eccentric motor. Tiny versions of these are in all sorts of haptic devices, like your phone or a VR controller, really anything that buzzes. So I hooked up my homemade eccentric motor to my ESP32, to my buggy compass chip, and when I faced my compass chip in a random direction, the motor went off. It was awesome, but I still needed to solve this compass problem. And this ended up being a way bigger problem than I thought, because it turns out the Earth's magnetic field is pretty weak, and the magnetic fields that humans generate through like a speaker or a magnet, both of which are all over your phone, which is in your pocket, which is next to your belt, have way more force than our magnetic field does. But we need this pigeon belt to buzz when it's facing north, when it's inside of a building, when it's out on the street, when it's in the middle of nowhere, and we need us to do it totally consistently, or else our body's intuitive sense of direction will be intuitively completely wrong. So then I started to dig into why this is such a hard problem to solve, and it turns out it's just difficult. I got a little too deep in the physics of Hall effect senses, and I realized that phones combine a bunch of sensors, magnetometers and accelerometers and tilt sensors and even GPS to figure out which way the phone is facing. And even then, we've all had that moment where we start GPS, we put our phone in the car to start driving, and it thinks we're facing the wrong way. And you're just like, bruh. But eventually I asked some friends who recommended the BNO055 orientation chip, which combines many of those sensors that are inside of a phone, and it aggregates them all, and it does some fancy math all on its own to output a heading number, which is basically like which direction are you heading when you plug it into an ESP32. It was like 10 times more expensive than the crappy compass chip, but you sometimes get what you pay for. When the chip came, I soldered the pins on, I connected it to my ESP32, I loaded on some test code, and it wrote north whenever it was facing north. Woohoo! North, sleigh. And with the compass working, now we were ready to miniaturize. At this point, I had what was called a V0, a version 0, a minimum viable product. It does basically everything that the final product will do, but is way too huge, messy. It has no power source. It has to be plugged into a computer. And it looks a little like I'm gonna get on some watch list by wearing it. First, I got rid of my hand-done eccentric motor and just used a itsy-bitsy tiny one to save space. Then I replaced my ESP32 with a smaller Shao microcontroller and realized in the process that xiao in Chinese means small. Love that. And while I was at it, I rigged up an LED in addition to the eccentric motor to go off 2 different pins of the xiao so that I would know that the device was on and measuring orientation, even if it wasn't facing north. I wanted some kind of feedback there. And so I wrote code that has the inverse logic, where the buzzer only buzzes when it's facing north. The LED would be on all the time that it wasn't facing north. It sounds a little convoluted, but believe me, it ended up feeling really intuitive to use.
Vibrates when it's facing north. Oh, it's so sick.
And then I soldered on a little tiny LiPo battery under the bottom of the xiao. The xiaos are so small that they don't even give you pins to put a battery in. You have to just go to these little exposed copper pads on the bottom. And then I decided to put all of this on a much smaller prototype breadboard. And that's where the scariest started.
So crazy. Oh my God.
Because this thing that I had made, it worked. All these little wires worked. They were connected from the correct pin on the microcontroller, which had the correct piece of code addressing it to the correct component in the correct way. And it was like, oh, it's such a fragile thing to get going. And in order to transfer the whole thing onto a smaller breadboard so that it would fit in the belt buckle, I would have to take the whole thing to pieces and solder it in a much more permanent way. But I had to do that because this belt will have to withstand footsteps and jostling and taking on and off. A wire plug-inable breadboard just wouldn't work for that. But I was totally terrified because one mis-soldered connection could completely fry the whole thing or make none of it turn on, and it would be really, really, really hard to debug what was going on. So first I decided to take a photo of my working breadboard so that I could just copy that up for my new prototype board. But a photo has parallax, a photo has perspective. And so when you think a certain wire is plugged into one pin, if you actually were to look at the breadboard, you'd see it's plugged into a different pin that was actually kind of behind that. So if I only referred to photos, it was going to be very likely that I would solder something wrong. And instead, I did something that I've never done before, and it's such a beautiful hack that I would totally recommend it to anyone who's watching this and likes fiddling around with electronics. I scanned the whole thing into a Gaussian splat. Now, I used Polycam for it, but there's a bunch of different apps that you can use to make Gaussian splats. And basically, I took about 150, 200 photos from every angle of my little breadboard, and then I fed them all into an algorithm, and what it came out with was a 3-dimensional model that picked up with incredible detail all of the wires so that I could see them in 3D. I had this 3-dimensional digital twin of my breadboard that once I unplugged everything, I could still refer back to make sure that when I was soldering, I was putting everything in the right place.
Like, you don't know if this red port is plugged into 3BO or V-in. It seems like it's plugged into 3BO, but that's bullshit. Because you go here and you're like, oh my God, that red port is plugged into V-in.
So then I fired up my soldering iron and got to work. And wire by wire, I deconstructed my beautiful working prototype and soldered it on to the front and the back of this prototype board to save space. And after 2 nerve-wracking hours of soldering, I turned it on and the LED turned on. I was like, okay. And I rotated it around. And then when it was facing north, it vibrated. It was the coolest moment.
Behold, the first prototype of Pigeon belt.
Never in my career as a maker has something worked flawlessly the first time. And I truly credit this to the Gaussian splat that I had made, that I could just like follow this 3-dimensional map. It was amazing. Honestly, it was such a relief. Then I just needed to design a casing for it. So I hopped into Fusion 360. I made a few prototypes. This is the 3rd or 4th prototype of it. And I 3D printed them all in PLA. And shout out to my partner, Julia, who drew this adorable pigeon wearing a cute little cowboy hat and with a little ascot tie, who's just like exploring the world so proudly that we 3D printed onto the front of this guy. And then I connected it to an old cowboy belt that my partner's granddad had lying around. And the reason it looks like metal is because I brushed the surface of it with this strange paint called Rub and Buff. I think, is it called Rub and Buff? It's so crazy. Rub and Buff. Yep. Rub and Buff. Looks a little bit shiny. It also looks a little bit worn. And I screwed everything down, put it on, turned it on, and went outside. Now, the most surprising thing about this belt is that it pretty much just works. For all of my issues with getting a chip to point north, it turns out that the more expensive components pretty much solved the issue. The second surprise is that you're actually not often facing due north when you move around the world. Like my entire walk from school to home is actually just like south and east. Your body doesn't really get much feedback about which direction it's facing unless you're spinning around. So I may try to modify the code to put a double tap when you're facing south, but I'm super open to your ideas and suggestions about like what other functionality can we add to this to give your body this more of an intuitive sense of what direction it's facing. And then the last thing I realized while actually using the Pigeon belt is it's subtly difficult to ride the line between intrusive and helpful. Like sometimes the buzzing was incredibly subtle and in the background and I didn't even notice it, and my body was just like, ooh, that's what direction it's facing. And it was cool. I would get these glimmers of like, huh, that's north? I always thought that was west. And that was really beautiful. But sometimes, like when you're walking due north and every single footstep is rotating your hips just slightly in and out of the window of facing north, then it's just like buzz, 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 buzz. And I think I just need to modify the code to have a north window of like north plus or minus 5 degrees, but then a turned away window where it won't buzz again until you've turned a really significant amount beyond that window. But the funny thing here is that like with the hardware finally done, the software is the thing that needs to get dialed in. And then to be completely honest here, the last challenge is around this compass sensor. It's so much better than the original one, and sometimes for whatever reason it just gets out of whack and you're not facing north but it thinks you're facing north. In those situations you just have to turn it off and on again and let it recalibrate. But I don't know what a solve for that would be besides creating a whole Bluetooth connection to your phone so that it could use all of your phone's brain to figure out compass heading. And I really don't want to do that because again, the whole point of this belt is to be phoneless, to be not looking it down at the screen, not even carrying your phone, just exploring the world, nothing between you and the world, just your body in space. So that's the Pigeon belt. Let me know if you would wear it, if you think this is useful or stupid. I genuinely feel like it's somewhere in between, and my favorite part of this process is just the fact that this idea that I had a couple decades ago, I've now been able to turn into a real physical product, and that is just such a joy. If you want to see more stupid ideas turned into reality, then hit subscribe. Thank you for watching. See you next time.